The origin of mountains. Mountains are among the most impressive and enduring features of the Earth's surface. Rising high above surrounding landscapes, they shape climates, influence ecosystems, and have played a crucial role in human history and culture. The formation of mountains, known as orogeny, is a complex geological process that occurs over millions of years and is closely linked to the dynamic nature of the Earth's crust. The primary cause of mountain formation is the movement of tectonic plates. The Earth's lithosphere is divided into several large plates that float on the semi-molten mantle beneath them. These plates are constantly moving, though very slowly, typically only a few centimeters per year. When tectonic plates interact, enormous forces are generated, and these forces can create mountains. One of the most common ways mountains form is through the collision of continental plates. When two continental plates move toward each other, neither plate easily sinks into the mantle because both are relatively light. Instead, the crust is compressed, folded, and thickened. Over time, this process causes the land to rise, forming vast mountain ranges. The Himalayas are a classic example, created by the collision between the Indian plate and the Eurasian plate. This process is still ongoing, and the mountains continue to rise today. Mountains can also form when an oceanic plate collides with a continental plate. In this case, the denser oceanic plate is forced beneath the lighter continental plate in a process called subduction. As the oceanic plate descends, it melts due to intense heat and pressure, producing magma. This magma rises to the surface through cracks in the crust, leading to volcanic activity and the formation of volcanic mountain chains. The Andes Mountains in South America were formed in this way and include many active volcanoes. Another important type of mountain formation occurs at divergent plate boundaries, where tectonic plates move away from each other. As the plates separate, magma rises from the mantle to fill the gap, creating new crust. This process can form underwater mountain ranges called mid-ocean ridges. Although these mountains are mostly hidden beneath the oceans, they represent the longest mountain system on Earth. Not all mountains are formed by plate collisions or volcanism. Some mountains, known as fault block mountains, are created when large blocks of the Earth's crust are lifted or tilted due to tension and faulting. The Sierra Nevada range in the United States is an example of this type of formation. In other cases, erosion plays a key role. Over long periods, wind, water, and ice wear away softer rock, leaving behind more resistant material that forms isolated mountains or plateaus. Once mountains are formed, they are constantly reshaped by external forces. Weathering and erosion gradually break down rock, carrying sediment to lower elevations. Glaciers carve deep valleys, while rivers cut through mountain slopes. Although these processes slowly reduce mountain height, tectonic activity can continue to uplift the land, creating a balance between destruction and renewal. In conclusion, mountains are not static structures, but the result of ongoing geological processes. Their formation reflects the powerful forces within the Earth and the constant movement of tectonic plates. Understanding the origin of mountains helps us better appreciate the dynamic planet we live on and the long timescales over which its surface has evolved.